So this exercise related to the space physics, we have already done uh, first 10 questions from this exercise. So we will do question 11 and 12 today. During the session, you can use your mic or a chat to participate. The diagram 1 shows the orbit of Mercury and the orbit of the Earth. So you can see the two orbits are shown, the orbit of the Mercury and Earth. Describe two differences between the orbit of the Mercury and orbit of the Earth using using diagram 1 to help your answer. Like you have to use this diagram to help your answer. Can you identify the two differences between the two orbits of Mercury and Earth? Yes, you can use your mic or a chat to state the answer. I prefer that you use your mic so that it will save time. So how the two orbits are different from each other, the orbit of the Mercury and the orbit of the Earth.
The space from the orbit of the Earth from the Sun is more from Mercury to Sun.
Okay. So you can say the orbital path, the length, the circumference of the path is different. Like Mars is having a smaller orbit or Earth is having a larger, that's one thing. What else from the figure? Yes, that's also good. One is more elliptical. Yeah, that's right. The Mars has more elliptical orbit as compared to that of Earth. That's good. You can also mention they have a different radius. You can mention they have a different length or circumference of the orbit. You can mention they have a different speeds or different time period as well. Like Earth and Mercury are not taking the same time to move around the Sun. So yeah, the time will be different as well. So any two you can mention. It's up to you which one you want to. But because the question is use diagram to help your answer, so one of the mark is related to using a diagram and you can identify that they have different lengths of the orbit. No, one of the point is by using the time is, if you remember, there was one table about the orbital time of the planets. You have to recall that to work out which one take more time and which one is taking a short time. So orbital time periods are, you cannot identify from this as they have different speeds. So different lengths are there and one is on Mars, the Mercury, sorry, more eccentric. The next one, the diagram 2 shows the orbit of a comet and the orbit of the Earth. Describe two differences between the orbit of a comet and orbit of the Earth and use diagram 2 to help your answer. So you can see one is the orbit of the comet, another one is the orbit of the Earth. What are the two differences in these orbits? So orbit of the comet is elliptical, orbit of the Earth is circular, that's good. That is one thing. And then the second point, so they have like the orbit, they will have different path lengths are also there that you can see the length of the orbit is also different. So one point you can mention more eccentric. for comet as compared to Earth is circular, and they have a different path length or orbital path length. So for a comet, it's more eccentric, and they have a different length. And if you check another thing, the sun is approximately at the center of the orbit of the Earth, but for comet, it's not at the center. You can mention that point as well. The position of a sun with reference to the comet. Next question, a similar question. There are words in the box. Diagram 1 shows an orbit of two objects. You can see two different. Select a word from the box to add the three missing label of diagram 1. So if I say comet, that's right. Planet and the star. Because they're all moving around this star. So this one is a planet because planet move around the star. Comet also. Comet is having a more eccentric path as compared to that of a planet. And whenever we are solving a question related to a planet, we consider that it's circular because we apply the rule that speed is equals to distance divided by time by considering it's a circular path. The diagram 2 shows a moon orbiting the Earth, as you can see. Draw an arrow on the diagram to show the gravitational force of attraction or gravitational force acting on the moon due to Earth. You can use the screen annotation to complete. Draw an arrow to show the direction of the force acting on the moon. And you have to draw the arrow must be start from the moon, like it should be directed towards Earth. The next is give a name of a large collection of billions of stars. What we call when we have billions of stars together. Billions of stars together. That's called a galaxy. Yeah. Galactic bulge is galactic bulge is basically the region where we have stars, but when we have millions or billions of stars, that the right term, it's the galaxy. Galactic bulge is a part where the formation of a star can happen or occur. Like most of the stars in our solar system, we find in a galactic bulge. But it's a collection of billions of stars. So the correct answer for this one is even acceptable. Like if you mention any name of a galaxy, that's also acceptable. You write a Milky Way, that's also fine. You mention a galaxy, it's fine. Even you mention universe, that's also correct. In question 13, this question is about the stars. The diagram shows the orbit of two astronomical objects, object A and B. Add a label arrow to a diagram to show the type of the force from star acting on object A. You have to draw a label. So first draw an arrow to show where the direction of the force and then label that arrow as well. And then label as well, like what we call that force. That is gravitational. Yeah. So gravitational force, you can say gravitational pull, you can say. The next one, uh, you can use a screen annotation to state the answer. What is object A? Just a minute, I will zoom out so you can see both questions and then annotate. Yeah. What is object A and what is object B? So object A is a planet and object B is a comet. Moving on to the next part of this question. State the name given to large collection of billions of stars. It's a similar question. What we call when you have billions of stars together? What we call them?
Galaxy.
So we call them as the galaxy. Then the next, the physicists classify stars according to their color. Each group of stars of similar color is called a spectral class. The table gives information about the color and the surface temperature of the three spectral classes of star. The sun belongs to the spectral class G. And the surface temperature, you can see it's given about 5,600. Complete the table by suggesting a value of a missing surface temperature. So first you have to identify by the color, you can identify like which one is at high temperature and which one will be there at low temperature. So means, as you see, we have different colors, the spectral classes. I will show that table of the spectral class. So this is the table of the spectral class. So you can see as the star color changes, like when it is like red or yellow, orange, it is the coolest one. So if we have the temperature of the G class star, which is 5,600 Kelvin, and we have to complete for the stars which are red or a star which is blue and blue-white. So means if it is blue or blue-white, it will be hottest. And if it is red, it will be the coolest. So as we have to complete, yeah, you have to, even without learning a table, you can identify by the pattern as the orange and red star, the M class. It's better you memorize that. That's also good. So its surface temperature should be lower than 5,600. And where blue and white, the surface temperature, it's not like too low. Yeah, if you write it half, that's also fine, 3,000. But any value acceptable. Here you don't have to memorize the temperature. You have to identify if a class of a star is like blue or blue-white, it means it will have a high temperature. If it is red or orange-red, it will be low temperature. And yellow, green, it is green is not there, yellow is there. That is, it's having an like moderate temperature. So this question is not related to memorization. It's related to your understanding that M class star, which are orange and red, they should have a low temperature. And blue and white stars, spectral class B, they should have a high temperature. So any one value lower than 5,600 and another value higher than 5,000. Any value is acceptable. It's up to you, but it should be higher. So if you memorize a spectral class, it's fine. Like it's a good thing that you know you have understood. Here you can see the temperature are not given. So same thing, if I say in this table, if I say I have a star which is yellow in color, which is 5,600 Kelvin, and I say predict the temperature of a star which is blue-white. So it should be more than 5,600. Any value you write, most of you write 7,000. It's fine. And same thing, if I say predict the temperature of a star which is red, so it should be coolest, so its temperature should be lower. If you write 4,000, that's also fine. If you write half of it, 2,600, that's also fine. So it's the class of the star. Using that, you can identify its temperature. Then this question, there are stars in the universe with a mass much greater than the mass of a sun. So they're talking about the high mass star, the cycle of a high mass star. Describe what happened to these high mass stars when they leave the main sequence stage of their evolution. So this is about the stellar evolution, like what happened to this is a cycle you can see. So when we have the stars, this is a main sequence. We have to tell after main sequence what will happen. There will be a supernova and then it turn into a neutron star or a black hole. So high mass star, the pattern you have to tell. You don't have to mention how it become a main sequence. You have to tell what happened afterwards. So then what will happen? The star will become a supergiant or a red supergiant. Then there will be a supernova. And as a result of a supernova, it will leave a neutron star and a black hole. It's basically a supergiant, red supergiant, red giant. Red giant is acceptable, but normally it's a supergiant. Or even blue supergiant is also right term you can use. So the points which will score the mark, first thing, after the main sequence, the star will change to red supergiant, or you can say supergiant. Then after supergiant, there will be a supernova. And from supernova, it leave behind the neutron star and the black hole. So this is a cycle of the star which you have to remember for the high mass star. If it was for the low mass star, then it will be a red giant, then it will be planetary nebula, white dwarf, and theoretically black dwarf. Otherwise, high mass star cannot remain in a main sequence for a longer period of a time, so it turned into red giant, supernova, and then a neutron star and a black hole. So these are from question 11 to 14 we did today from the exercise space physics.